Welcome back, everybody. Go ahead and find a comfortable spot, maybe dim the lights a little, or if you're driving, just settle in and let the road stretch out in front of you. Today, we are going to go on a journey that is, quite frankly, staggering. We are going to stand at the very edge of the universe, peer into the absolute beginning of time, and then we're going to turn that lens completely inward, right into the deepest architecture of your own mind. We're diving deep into a fascinating, mind-bending text called Big Bang and the Buddhist Worldview, or in its original Vietnamese, Big Bang Va Vu Tru Quan Phat Jiao, written by the brilliant thinker Tien Zhang. This isn't just a book about science, and it's not just a book about religion. It is a profound exploration of the intersection between modern astrophysics and ancient Buddhist cosmology. It's an argument that science, for all its miraculous achievements, is currently hitting a wall, a crisis of observation versus theory, and that ancient Buddhist insights into the nature of reality, impermanence, and the interconnectedness of mind and matter offer us the exact framework we need to not only understand the universe, but to survive it. Let's start with a question that every single one of us has asked at some point, usually when we're kids looking up at the night sky. It's a question that sounds so simple, almost naive, but it has terrified and baffled the greatest minds in human history. The question is this: what existed before the Big Bang? Think about that for a second. For decades, the ironclad scientific consensus, the textbook answer, was that this was a nonsense question. It was like asking, what is north of the North Pole? According to the traditional Big Bang model, time and space themselves were created in that initial, incomprehensible explosion. Therefore, asking what happened before time existed is a logical impossibility. There was just nothing. But nothing is a deeply unsatisfying answer to the human mind, isn't it? Tien Zhang points out that recently, this traditional view has started to fracture. The before question is suddenly a hot topic in the halls of theoretical physics. We are seeing a massive paradigm shift. New hypotheses are emerging that suggest the universe didn't just pop into existence from absolute zero, from a void of nothingness. Instead, we are looking at ideas like the theory of multiple Big Bangs, the idea that our universe is just one bubble in a boiling pot of cosmic soup, where countless small Big Bangs are constantly occurring, creating different pockets of an ever-renewing, infinite multiverse. Then there is the oscillating universe theory. I love this one because it feels so organic. Imagine the universe not as a one-time explosion, but as a heartbeat. It expands outward from a Big Bang, stretching and cooling, until billions of years later, gravity finally grabs hold of the reins, slows the expansion, and pulls everything back inward. It contracts, faster and hotter, pulling all matter, all galaxies, all stars back into a single, infinitely dense point, a big crunch. And then? Another Big Bang. A cosmic inhale and exhale. Expansion, contraction. A heartbeat that lasts for trillions of years. But why does this matter? It matters because, as the author notes, challenging the established Big Bang model is actually professionally risky for a scientist. The academic world is built on consensus. If you are a physicist and you stand up and say, I think the standard model is wrong, you risk your funding, your tenure, and your reputation. The mathematical equations describing the standard Big Bang have become incredibly complex, almost impenetrable, but they are also becoming, as the text suggests, less imaginative. Science has backed itself into a corner where the math works on paper, but it's becoming increasingly divorced from the messy, infinite reality of the cosmos. To understand how we got to this crisis, we have to look at the historical genesis of the Big Bang theory. It didn't just fall out of the sky, it was constructed, piece by piece, by human beings with their own biases and blind spots. Let's rewind to 1917. Albert Einstein, the titan of modern physics, has just developed his theory of general relativity. But Einstein had a philosophical bias. He believed the universe was static, closed, and eternal. It didn't expand, it didn't shrink. It just was. In fact, when his own equations suggested the universe should be collapsing under its own gravity, he introduced a fudge factor, the cosmological constant, just to keep his mathematical universe sitting still. He later called this his biggest blunder. Then, in 1924, a Russian mathematician named Alexander Friedmann looked at Einstein's equations and said, "No, wait. The math says the universe is expanding." A few years later, in 1931, a Belgian priest and physicist named Georges Lemaitre took this idea to its logical conclusion. Lemaitre reasoned that if the universe is expanding today, then yesterday it must have been smaller. And 1 billion years ago, it must have been even smaller. If you rewind the tape all the way to the beginning, the entire universe must have been compressed into what he called the primeval atom. Lemaitre used the laws of thermodynamics, specifically entropy, to argue that the universe began in a state of maximum order, and has been expanding and cooling into disorder ever since. Here is a piece of historical irony for you: the term Big Bang was actually an insult. In 1950, a brilliant astronomer named Fred Hoyle was on a BBC radio broadcast. Hoyle hated the idea of a universe with a beginning. He preferred a steady-state universe. So, to mock Lemaitre's theory, he dismissively referred to it as this Big Bang idea. But the name was so catchy it stuck. The debate raged until 1965, when two scientists, Arno Penzias and Robert Wilson, were working with a giant microwave antenna in New Jersey. They kept picking up this strange, persistent background noise, a static hiss that came from every direction in the sky, day and night. After checking everything, even cleaning out pigeon droppings from the antenna, they realized what they were hearing. It was the cosmic microwave background radiation. It was the literal echo of the Big Bang, the cooled-down afterglow of creation. That discovery seemingly ended the debate. The Big Bang became the undisputed king of cosmology. But here we are today, and the king is losing his crown. The primary conflict in physics today is that our two best ways of understanding the universe absolutely refuse to speak to each other. On one hand, you have general relativity, Einstein's masterpiece, which perfectly describes the macro-universe, gravity, planets, stars, and galaxies. On the other hand, you have quantum mechanics, which perfectly describes the micro-universe, atoms, electrons, photons, and quarks. But if you try to combine them, which you have to do if you want to understand the Big Bang, a moment when the entire massive universe was compressed into a microscopic quantum dot, the math breaks down. It spits out infinities. It makes no sense. And scientists are trying to bridge this gap with incredibly beautiful, elegant mathematical theories like string theory. But as Tian Zhang points out, these are unproven. Our current particle accelerators, even the massive Large Hadron Collider in Switzerland, are nowhere near powerful enough to verify these theories. This brings us to the current, bleeding-edge crisis in cosmology. We are living in the golden age of telescopes. With the Hubble Space Telescope, the Keck Observatory in Hawaii, and now the James Webb Space Telescope, we are looking further back in time and deeper into space than human beings ever thought possible. And what are we finding? We are finding that our observations are cracking the old models wide open. The author quotes experts like Patrick Petit-Jean from the Paris Institute of Astrophysics and Olivier Lefebvre from the Paris Meudon Observatory. These are heavy hitters in the scientific community, and they are openly stating that the old models are crumbling. The era of legendary theories, where theoretical physicists could just invent beautiful math without observational limits, is over. The telescopes are acting as a brutal reality check. For instance, there are massive debates right now about the actual age of the universe. We thought we had it pinned down to about 13.8 billion years, but new observations of star movements and cosmic expansion rates are throwing wrenches into those calculations. And then there's the elephant in the room, the missing mass. When physicists look at how galaxies rotate, There isn't enough visible matter, stars, planets, gas, to hold them together. They should fly apart. So, to make the math work, science invented dark matter and dark energy. We are told that 95% of our universe is made of stuff that we cannot see, cannot touch, and cannot interact with. We only know it's there because of its gravitational shadow. Think about the profound humility that requires. All of human history, all of our science, our chemistry, our biology, the earth, the sun. Every star you see in the night sky, that only makes up 5% of reality. The rest is missing. Now, why is science struggling so hard to find this missing reality? This is where Tian Zhang's text makes a breathtaking pivot. What if the problem isn't out there in the stars? What if the problem is in the observer? What if the map is broken because the mapmaker forgot to include themselves? Enter the Buddhist intersection. Buddhism, an ancient spiritual tradition, steps up to the modern physicist and says, "You cannot understand the universe by only looking outward. Because the universe is a product of consciousness. You cannot separate the subject from the object." This is where ancient Eastern philosophy perfectly mirrors the most mind-bending discoveries of quantum mechanics. Specifically Heisenberg's uncertainty principle. In the 1920s, Werner Heisenberg discovered that at the quantum level, the very act of observing a particle changes its behavior. You cannot measure both the exact position and the exact momentum of an electron at the same time. The closer you look at one, the fuzzier the other becomes. But it's deeper than just a measurement problem. The implication is that at the fundamental level of reality, the observer is entangled with the observed. The boundary between matter and energy, between the physical universe and the conscious mind looking at it, is not a solid wall. It is permeable. It is an illusion. Buddhism has been saying this for 2,500 years. Science struggles with finding an objective truth because the scientific method is still fundamentally rooted in the ego of the scientist. We believe we are separate individuals, sitting inside our bodies, looking out through the windows of our eyes at a universe that exists completely independent of us. But Buddhism introduces the concept of anatta, or no self. This is a difficult concept for the Western mind to grasp. We are obsessed with the self. But Buddhism argues that nothing in the universe, including you, has a fixed, permanent self-nature, or svabhava. Everything is in a state of constant, infinite flux. You are not a static object, you are a process. Think of a river. You can point to it and say, "That is the Mississippi River." But the water you are pointing at is gone a second later, replaced by new water. The river banks are eroding and changing shape. The river is never the same river twice. Buddhism says you are exactly like that river. The cells in your body are dying and being replaced. Your thoughts, your emotions, your memories are constantly arising and passing away. The you that started listening to this podcast is not the exact same you listening right now. The subsequent state is never identical to the previous one. Why does this philosophical deep dive matter to cosmology? Because if you approach the universe with the ego, with the belief that you are a separate, permanent entity trying to conquer and categorize external, permanent objects, you will eventually hit a wall. You will invent dark matter to fill the gaps in your equations, rather than questioning the fundamental nature of your own perception. This leads directly into the ethical implications of science, which is a major theme in Tian Zhang's work. The author offers a stark, urgent critique of pure science. We have seen what happens when scientific discovery is divorced from an ethical foundation. Without a moral compass, the brilliant insights of physics become nothing more than tools for personal greed or national ambition. We unlock the secrets of the atom, the very binding energy of the universe. And our first instinct was to build a bomb that could vaporize a city in a fraction of a second. Science without ethics is an existential threat to humanity. The author argues that the Buddhist theory of no self is not just a neat philosophical trick, it is the absolute prerequisite. the true moral foundation for a future technical civilization. If we deeply understand anatta, if we realize that we are intimately, inextricably connected to every other living being and to the planet itself, because we share the same fluid, interdependent nature, then destroying our environment or bombing our neighbors becomes as absurd and suicidal as your right hand deciding to cut off your left hand. We need a science that serves the whole, not the ego. To illustrate this profound shift in perspective, the text contrasts the starting points of science and Buddhism through the lens of existential inquiry. Science looks at the sky and asks, what existed before the creation of heaven and earth? It's an external question. It requires telescopes, equations, and particle colliders. Buddhism, specifically the Zen tradition, turns that question entirely inside out. It asks, who was I before my parents were born? I want you to really let that question sink in. Who was I before my parents were born? It's a classic Zen koan. A koan is a riddle without a logical answer, designed to short-circuit your rational, ego-driven mind. It forces you to stop looking for a biological or historical answer and to look directly into the nature of your own consciousness. The goal of these two questions reveals the fundamental difference in their paths. Science seeks external answers. It wants to map the universe, catalog the stars, and harness energy. But Buddhism seeks internal liberation. The Buddha wasn't interested in building a telescope. He was interested in ending human suffering. Yet, and here is the absolute magic of this text, the Buddha's descriptions of the universe, made 500 years ago while sitting under a Bodhi tree, were shockingly accurate. Obviously, humanity back then lacked the technical vocabulary of modern physics. The Buddha didn't use words like quasars, nebulae, or cosmic microwave background. His descriptions were qualitative and general. But his direct intuition, his enlightened state of consciousness, allowed him to see the structure of the cosmos in a way that modern science is only just now verifying. Let me give you some specific, mind-blowing parallels that the author highlights between Buddhist cosmology and modern astrophysics. First, let's look at galaxies. In Buddhist cosmology, there is a concept of kiliacosms. The ancient text describes small, medium, and great world systems. A small world system consists of 1,000 suns and 1,000 moons. A medium world system is 1,000 small world systems. And a great world system, a completely unfathomable expanse of space, is 1,000 medium world systems. It's a cosmic Russian nesting doll. When you read those ancient sutras today, it is impossible not to see the exact structural hierarchy of modern astronomy. A small world system is a solar neighborhood. A medium world system is a galaxy, like our Milky Way, swirling with billions of stars. And a great world system is a galaxy cluster, or a supercluster, woven into the cosmic web. The Buddha described a multiverse of staggering scale, teeming with countless worlds, millennia before the telescope was even a concept. Second, let's look at universal laws. Modern science is currently debating the life cycle of the universe, the oscillating models, the multiple Big Bangs, the constant recycling of stardust. Buddhism codified this long ago as the 4 stages of existence: sin, true deed, diet. This translates to birth, stay, change, and extinction. Everything in the universe, from a subatomic particle to a human thought, to a supermassive black hole, follows this cycle. It is born, sin. It exists for a period of time, appearing stable, true. It inevitably degrades and transforms, d. And eventually it passes away, returning to the void, diet, only to provide the raw material for the next birth. The Big Bang is sin. The billions of years of cosmic expansion is true and d. The Big Crunch, or the heat death of the universe, is diet. It is the ultimate universal law of impermanence, perfectly echoing the modern understanding of the life cycle of matter and energy. Third, there is the concept of infinity. The traditional Western view, heavily influenced by Abrahamic religions, is that the universe has a strict, linear timeline. There was a definitive beginning created by a deity, and there will be a definitive end. But Buddhism describes a universe that is anadi ananta, without beginning and without end. It is an infinite, self-sustaining process. There is no single creator deity standing outside the universe, turning the crank. The universe creates itself, constantly, through the interdependent causes and conditions of everything within it. It's a breathtakingly modern, almost quantum view of reality. So, where does all this leave us? Where does the physicist go from here? Tian Zhang concludes the text with a powerful call for scientists, and really, for all of us, to deeply reflect on our roles in this vast, interdependent system. There is a beautiful anecdote shared in the book about the famous physicist Fritjof Capra, who wrote The Tao of Physics. Capra was deeply immersed in the parallels between quantum mechanics and Eastern mysticism. At one point, he went to an Indian sage and asked a question that was weighing heavily on his heart. He asked, "Do I have to abandon my science to study the way? Must I give up physics to achieve spiritual enlightenment?" The sage looked at him and gave an answer that should be carved into the stone above every university and laboratory in the world. He said, "You must be a real human being first, before being a specialist." That is the crux of the entire argument. You must be a real human being first. You must understand your own mind, your own heart, and your own interconnectedness with the fabric of reality, before you start splitting atoms or mapping galaxies. Buddhism, in this light, is framed not as a religion of blind faith, but as a true science. It is a science of the mind, aimed at creating genuine peace and freedom. It recognizes that mapping the external universe is meaningless if the internal universe is in chaos. A true universe, according to this worldview, is not just a collection of dead rocks and burning gas floating in a vacuum. A true universe is one where the driving forces of sentient life are no longer what Buddhism calls the three poisons: tam, san, si, greed, anger, and delusion. Think about how much of our modern world, our technological progress, is driven by those three poisons. Greed drives us to strip mine the planet and hoard resources. Anger drives us to invent increasingly horrific weapons of war. Delusion drives our ego, making us believe we are separate, superior, and immune to the consequences of our actions. The Big Bang created the atoms in our bodies, but it is our consciousness that decides what to do with them. We are literally the universe waking up and looking back at itself. The Hubble and James Webb telescopes are the universe's eyes. Our particle colliders are the universe trying to understand its own atomic structure. But until we conquer greed, anger, and delusion, we are a universe at war with itself. The ultimate vision of Big Bang and the Buddhist worldview is a synthesis. It's a hope that the incredible, rigorous, mathematical brilliance of modern science can be married to the profound, compassionate, ego-destroying wisdom of Buddhism. It tells us that the universe is cyclical, that our models are incomplete, and that mind and matter are a unified dance. It reminds us that the Buddha, sitting quietly with his eyes closed, saw the exact same infinite, swirling galaxies that we now see through billion-dollar lenses in space. He saw the birth, stay, change, and extinction of all things. And he left us a map, not just to understand the cosmos, but to liberate ourselves from the suffering within it. So the next time you look up at the night sky, don't just ask what came before the Big Bang. Ask yourself who is doing the looking. Ask yourself how you can live a little more connected, a little less driven by ego, and a little more aware of the infinite, beautiful, fleeting river of reality that you are a part of. Take a breath. Let that sink in. We are all stardust, but more importantly, we are all conscious. Let's act like it.